9.1, it says identify one-to-one functions. It says there's no f of A and f of B, so they're not equivalent. All right, so basically what you're looking for is a duplicate. You cannot have two different x values going to the same y value. So you have an x here and an x here, but they're both traveling to the same y. So therefore, this is not one-to-one. In the next case, everything, none of the x's duplicate and none of the y's duplicate. So this one is one-to-one. You can also say 1-to-1, the same thing. Again, this 1-to-A is not one-to-one because you have duplicate y's. And then this is supposed to be x, and this is supposed to be f of x, which is equal to y. And this is one-to-one. Then if you look down here, it's asking if the horizontal line test worked, because if it doesn't, then it's not one-to-one. So let's see. The horizontal line test definitely works here because all of this is one-to-one. It only crosses the point once. Horizontal line test is a fail here. So this is 1-to-1. This is not. And then this one, it looks sneaky, but this is actually 1-to-1. So this is 1-to-1. Definition of one-to-one. So you're just basically going to determine the one-to-one formula. You're going to switch the x and the y's. So we rewrite this one. It's y equals 3x plus 2. Switching x and y's means it's going to be x equals 3y plus 2. So this is step 1. And then we color code it. And then we have step 2 that says solve for y. So step 2 is going to be where we solve for y. That's going to be x minus 2 divided by 3 equals y. And then step 4, or 3, excuse me, is going to be where we take this and replace the notation of y. So that's going to be x minus 2 over 3 equals inverse. Determine if they're inverses of each other. And they just mean what's on the graph. All you're doing is looking for symmetry on y equals x. So that's the first clue. Let's make this a bright line. Let's use orange. So what you'll notice about the symmetry on y equals x is that this line is also known as the identity. So this is the identity function. Another quick way of doing this is you want to switch domain and range, which means when you have an xy for the f's, for the inverses, you're going to have a y comma x. Okay. Here's an example of that. When you're looking at this graph a little bit more intentionally, let's say we pick a point on the graph. We're going to pick this point right here. And this is going to be -2, 1. On this dotted graph, it should be, if we switch the x and the y's, it should be 1, -2. So let's see if we find that point. So I have 1, negative 2. And that's the point right here. So therefore, they're inverses. Then give the domain and range of each. So let's graph this first, negative 4 comma negative 2. So then the inverse is going to be negative 2 comma negative 4. This one is negative 3 comma 1. The inverse 1 comma negative 3. This one is going to be 1 comma 2. The inverse is 2 comma 1. Oh, negative 1 comma 2. So the inverse is actually 2 comma negative 1. And then this last one is 1 comma 4. The inverse is going to be 4 comma 1. And then we connect the dots. And as you see, they do mirror each other across the line of symmetry. Again, the line of symmetry is y equals x. All right, so let's do the domain. It has to be an interval notation. The domain of f is negative 4 to 1. The range is negative 2 to 4. The domain, you just switch them. And then you switch domain and range. So the domain of the inverse, which is in blue, is going to be negative 2 comma 4. The range of the inverse is going to be negative 4 comma 1.